So this is the GEET engine, right?
This is the GEET engine, yes.
Okay, and so literally you could fill this thing up with, I don't know, 8/10 water and 2/10 gas, or 2/10 diesel maybe, or something like that, or?
Yep.
That's amazing.
So what liquid are we using here, for example?
Right now we're using regular gasoline with sugar mixed in with it.
And do you have this online?
We do have a website, yes. It's GEET.com.
Oh, okay, GEET.com. So this is the official one then.
Yeah.
Awesome, awesome.
Yep, this is from the original inventor.
Well, now isn't one of the things that makes this unique the fact that it's got some implosion, right? Because I think Ben, right, described it to me yesterday.
Yeah.
Ben was
the combustion in the cylinder is not necessarily an explosion. They believe it's actually more of an implosion. I'm not exactly sure how that works.
Yeah, it pulls the cylinder instead of pushing it, right?
Yeah.
Yeah.
So there's some scientists who've done some research tend to believe that's what's happening as opposed to an explosion. So.
Yeah,
that
it's
would
remarkable.
explain why it runs cooler, because an implosion is an endothermic reaction.
Yeah, that makes a lot of sense. This is wonderful.
But it still
stuff.
generates enough heat to run the reaction itself. So. But I don't know if you got down and felt the exhaust. It's actually a lot cooler than the exhaust you'd feel.
Oh, okay. Well, the exhaust is right.
The exhaust is right here.
Ooh, it's still hot there.
This will be extremely hot because this is where the reaction is taking place.
Oh, so the reaction is actually in your kind of your exhaust pipe,
Yeah.
then.
Okay.
But yeah, this is touchable. Your primary exhaust is touchable.
Well,
so
it's a little hotter now as the heat has been dissipating out through the metal. But during the reaction, the exhaust coming through from here is a lot cooler than like you'd feel on your lawnmower.
Okay.
Which is a comparable size engine to this.
So again, this is the GEET engine, and it runs off of pretty much anything.
Pretty much anything.
For using a larger vehicle, what are some of the chief advantages of the GEET engine, do you think?
Well, the chief advantage of using the GEET process is, number one, you have less heat, so you're going to have, your engine's going to last a lot longer because it's not going to get as hot. Because it's a plasma fuel, it's actually creating an electromagnetic field in the process, which as a result keeps your pistons from slapping around as much, so there's less friction, another reason why there's less heat. The fuel itself always fires top dead center for some reason, we're not exactly sure why, so you're not going to get pistons slapping around because of improper
so not a lot of knock probably, right?
Exactly. And the fuel, because it's so homogeneous and pure, burns almost 100%, so you don't get, and it burns evenly all at once, so you're not getting, it's not uneven burning, again, causing piston knocking and stuff.
Now, out of curiosity, have you guys been able to measure the exhaust to figure out what the reaction product is for this?
A couple years ago, we took this down to BYU and they tested it for us. They said that in the vapor going into the reactor, there were something in the neighborhood of 27 elements they were able to detect, and then the gas coming out the other side, there were only 11.
Oh, okay.
So, and the majority of that was hydrogen.
So hydrogen is the output. So this device can actually be used to manufacture hydrogen for electric cars, or not electric, but renewable energy cars.
It could be,
hydrogen
actually.
cars, whatever they call them.
If you use this little engine here to create the heat in a slave and then use an external vacuum pump, you could actually create and bottle it and then use it just like propane gas.
Oh, okay.
And that's another thing. You can use the GEET gas anywhere you can use natural gas or propane gas. You just have to change the size of the orifice because the molecule is a lot smaller.
Well, now one of the things that I'm kind of wondering about is, because a lot of the people that I know work with space-related applications, I see it almost looks like the exhaust is set up pretty uniquely in this. I'm wondering, in fact, it looks like your fuel runs directly into the exhaust, and the piston just pumps so it really doesn't have a flow through for fuel, kind of, or maybe it does. But
well, let me explain.
Would this thing work?
The fuel. The way it works is we've got in the bubbler here, we've got our fuel reservoir, and we use the steel wool just to break up the bubbles, so it's not.
Sure.
So it's not going to come up and get sucked up into the tube here. So our air comes in through here, down through that pipe to the bottom. It's bubbled up through the fuel where it sucks out as much as it can, gets saturated with the gasoline vapors. Then that vapor is pulled through the reactor, which is in the center of this. It's and inside the reactor tube itself is a rod, and it's the rod that actually does all the magic. It acts like the Earth. So what's happening here is we've got a thunderstorm, because this is pretty cool. The vapor coming through here is pretty cool. So we've got cold vapor coming this way. It goes through the reactor. It turns into GEET gas. That GEET gas is then mixed here with a little outside air to make it as combustible as we need it to be, and that's adjustable, and it's going to change as the gas gets used up. So that's why it's adjustable. That mixture is then pulled into the engine where it's combusted, and then the heat from the exhaust flows in this direction and then out the exhaust.
Now,
And it's that combination of the hot air flowing this way and the cold air flowing this way. You're creating a thunderstorm in there, and the little rod inside acts as the Earth. So it's grounding everything.
So in this little rod is really a vortex chamber, and you've got
It is,
flow
actually.
separation.
We've got
Flow separation between the hot and the cold, the incoming fuel and the outgoing exhaust.
Exactly.
Okay, and that makes a lot of sense.
So we're creating a plasma ball, basically.